In this video, we will look at a variety of functions and ask ourselves what is the parent function and what transformations have occurred. So that's what these directions mean. Identify the parent function and describe how the graphs are related. When they say how are the graphs related, they are asking you for the transformations. Meaning, is it shifted up, down, left, right? Is there a vertical stretch? Is there a horizontal compression? Is there a reflection over the x-axis? That's what we're going to work on in this video. So looking at number 4, if you take away any addition, subtraction, and multiplication, you're going to be left with the parent function. So the parent function must be the square root of x. So we need to graph that. And so a short table of values would be helpful. We can't put any negative values in here, but if x is 0, y is 0. If x is 1, y is 1. If x is 4, y is 2. I'm taking the square root. If x is 9, y is 3. So let's graph these points. So 0, 0, 1, 1, 4, 2, 9, 3. So this is what the parent function looks like. All right, now let's talk about the transformations. Compared to the parent function, we have this 3 here in the front. That is going to be a vertical stretch by a factor of 3. Okay, vertical stretch by a factor of 3. And if we look at the horizontal, because of the plus 8 that's in here, this is going to be left 8. Okay, is a translation or shift left 8. Okay, so we have a vertical change and we have a horizontal change. In terms of graphing this thing, that means we are going to need to change the y values because of the vertical stretch, and we're going to need new x values because of the left 8. Okay, so the new y values. Because of the vertical stretch by a factor of 3, that means that every y value will be 3 times the old y value. So my new y values will be 0, 3, 6, and 9. Those are my new y values. I'm also going to need new x values because of the left 8. Now we've learned that it's always the opposite of the way it looks. But when I do the actual calculations, if I want this thing to be left 8, I'm going to have to take each x value and subtract 8. Because of the left 8. So that means this new x value will be negative 8. 1 minus 8 is negative 7. 4 minus 8 is negative 4. And 9 minus 8 is 1. So these are my new x values and these are my new y values. So we can throw out the old y values, and these will be the new xy values. So negative 8 comma 0, okay, it's going to be, and negative 7 comma 3, and negative 4 comma 6, and 1 comma 9. So this is what the new function will look like. Okay, is that it? All right, so that's it for problem number 4. On problem number 5, again, if I take away any addition, subtraction, or multiplication, I will be left with the parent function. So the parent function must be f of x equals the absolute value of x. Okay, so I'm not going to need a table of values for this one. So the absolute value of x, well, we're supposed to write down the transformations. Well, you know what, I'm going to graph this first. So the absolute value of x is going to be a v. So it's going to be 0, 0, 1, 1, 2, 2. All right, the absolute value of 4 is 4, the absolute value of 5 is 5, and so on. Okay. But the absolute value of -1 is 1. The absolute value of -2 is 2. -3 is 3. The absolute value of -4 is 4, etc. So that's why it forms a V shape. So this is the original function. F of x equals the absolute value of x. Now let's talk about the transformations. There are 3 transformations here. The negative sign in the front is a reflection over the x-axis. Reflection over the x-axis. Okay, the 2, all right, ignoring the negative sign because that's a reflection, the 2 is a vertical stretch by a factor of 2. All right, and the +5 is going to be a shift left 5. So let's graph this. Because of the shift left 5, that's going to move the vertex over here to -5. Now, I know that this number in the front will be the slope of the right-hand side of the V. So, you know, the old slope was 1, but this slope is -2. So that means it should be going down 2 over 1. So this is the right-hand side of the V, and I'm using this number in front as the slope, like -2 over 1. Now this is the vertex. So the other side of the V has to be the mirror image. So now I'm going down to left 1. So that's it. This will be the graph of the transformation function g of x. Okay, so that is it for problem number 5. Looking at problem number 6, if you take away any addition, subtraction, multiplication, or division, you are left with the parent function. So the parent function must be f of x is equal to the square root of x. So this is the parent function. So let's go ahead and graph that again. All right, the same parent function we had a moment ago. And I'm just going to make the same table of values that I had before. You can't do negative numbers, so 0, 1, 4, 9. The square root of each of these is 0, 1, 2, and 3. Okay, so 0, 0, 1, 1, 4, 2, and 9, 3. Okay, so here is a graph of the parent function f of x. So now let's talk about these transformations. Dividing by 4 is the same thing as multiplying by 1/4. So I actually would be more comfortable if I wrote it this way. 1/4 times the square root of x plus 3. All right, these are the same thing. But in this form, it's easier for me to see that this is going to be a vertical compression by a factor of 1/4. Okay, and the +3 is going to be a shift left 3. So there you go. Those are the transformations. Because of the vertical compression, the y values are going to change. So I'm going to need a new y column. Okay, and the new y column will be 1/4 of the old y values. So 1/4 times 0 is 0. 1/4 of 1 is 1/4, okay, which equals 0.25 for graphing purposes. 1/4 of 2, okay, I'm saying 1/4 of 2, in other words, 1/4 times 2. This is like 2 over 1, so that would be 2 over 4, which reduces to 1/2, which equals 0.5. And then 1/4 of 3, well, that's 1/4 times 3, that's 3/4, which is 0.75. So these are my new y values. Okay, they are tiny. And because of the left 3, we will have new x values. Oh, you know what? I meant to do this in red as well. All right, so we will have new x values. And be careful, even though it is +3, we are going to the left 3, because it's always the opposite of the way it looks in here. So I really need to do x minus 3 because I want it to go to the left. So if I do 0 minus 3, that's -3. 1 minus 3, -2. 4 minus 3 is 1. And 9 minus 3 is 6. So I have my new x values and my new y values, so I can throw out the old x's and y's. So I should be able to plot these points, and that'll be the new function. So -3 comma 0 is right here. And -2 comma 1/4, okay, is right here, really tiny. +1 comma 1/2 is going to be right here. And 6 comma, why did I put 0.77? This is 0.75. That was weird. 6 comma 3/4. Okay, 6 comma 3/4 would be right here. All right, this is hard to draw because it's so short. Okay, so hopefully you can see that this graph has indeed been shifted to the left, and it is 1/4 of its original height. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.